Welcome to my channel Engineering Network. In this lesson I am going to show you how to prepare bar bending schedule of column and footing. Before we start, if you are new here, please subscribe to my channel and click on bell icon so that you will get notification on our each update. So now let's start. Here I have given a plan of column and footing, and according to this plan it is a square footing and the length is 48 inches and the width is also 48 inches, and the column that I have provided is also square column. It is 12 by 12 inches column. Now the steel that I have provided in this footing slab is number 4 at the rate of 6 inches center to center. Okay, so this steel will also be in same in the other direction as well, because it is a square footing. So now we have to calculate then how many number of bars that we have to provide in this footing slab. For that I have a formula which is now which is here the length of the footing. If you see here is a 48 inches. Now I have to divide this 48 inches, this length, by center to center spacing of the bars, which is 6 inches. So 48 divided by 6 and add 1. According to the rule you have to add 1 and multiply it by 2. Now why we will multiply it by 2? Because the steel that we provide in the footing is same in both direction. So I will calculate it for one direction and then for other direction I will multiply it with 2. So I have got 18 numbers of bar for footing slab. Okay, now I have to prepare bar bending schedule for this particular footing. You can see here uh, the steel, the bar is in a U-shaped bar. The actual length will be 48 inches, which is the length of the footing, and I will subtract the clear cover from both sides. From one side it is 1.5 and from other side it is also 1.5. So it the clear cover will be 3 inches. There are two hooks, one is 6 inches and the other one is also 6 inches, so it will be the extra length, which is a hook, it will be 12 inches. Now come here to Excel sheet. Serial number will be 1 and member name is a footing slab. Okay, I have already insert the bar shape for this particular bar, which is a U-shape bar. So if you see here, I have already provided in the barcode of U-shape. Actual length is 48 inches, which is the length of the of the footing slab. Clear cover is 3 inches. I already told you. And the extra length, bar extra, which is a hook length from both sides, it is a one from one side 6 and from other side also 6 inches. So it will become 12 inches, and there is no other extra length in this particular bar. So now I will to calculate the cut length. For cut length, I will do, I will subtract the clear cover from actual length and add the extra length to that actual length, so I will get the cut length. So for that, this is actual length, subtract, minus clear cover, and add this extra length. So I will get 57 inches of cut length. All the values are in inches. Now number of bars, as I already calculated, is 18 numbers, and now the member is one. It is one member, so it will be this. Now totally, what will be the total length in inches? I will insert equal sign and multiply cut length with the number of bars. So I will get 1026 inches the length of that, of 18 number of bars and footing. So to convert this inches and feet, divide this by 12, so you will get the answer. You use the calculator. 1026 divided by 12, so now it is 85.5 feet. 85.5 feet. And the diameter of this particular bar, if you can see here, we are using number 4 bar. So the diameter of number 4 bar, if you see here, the of diameter of this bar in inches is 0.5. Okay, it is the diameter, and the weight is 0.668 pound per feet. So I will insert the weight here. Okay, so this is the weight, the dia is 0.5. Okay, so this is the dia and the weight is 0.668. Okay, so now what I will do, I have to multiply this length with this weight. Okay, I will get the total length. This length in feet, I will multiply this with weight, so I will get the total weight 57.14 pound per feet. It will be in pound per it will be in pound, sorry, it will be in pound. Now this is the bar bending schedule for footing slab, and and after that I will calculate the I will prepare the bar bending schedule for this uh, column, and according to this cross section, the length of the whole column is 117 inches. But if you can see here, this column is also embedded in this footing slab as well. So what I will do, I will add this the length of this column with the height of this or thickness of this footing slab, and I will get 117 plus 12, so it is 129 inches the whole length of that column. Now after that I will subtract the clear cover from here. If you can see, this is the footing slab and this is 1.5 clear cover, and also there is two steels in both direction, and the diameter of that steel is number 4, which is 0.5 inches. It is two steel, one is 0.5 and the other one is also 0.5, so it will be 1 inches and the clear cover is 1.5. So if you add these two, you will get the clear cover of how much? 2.5 inches. So now what will you do? You will subtract that clear cover from that actual length. The actual length for that the main bars of column. If you can see here, mm, the main bars in that column is 4, and it is number 6 bar dia, 4 number 6 bar dia. So here serial number 2, and here I will insert mm, column main bar. Okay, and here, okay, now if here in this cross section, the shape of this bar is an L shape bar. It is an L shape, so I already added the L shape barcode. Okay, the actual length is 129. Okay, and the clear cover is 2.5. Okay, there is also hook as well, which is 12 inches, and it is in one bar. Okay, so first now I am preparing this bar bending schedule for one bar. Okay, so so I will put here 12 inches. Now the cut length will be, it is the same formula, actual length minus clear cover plus there is extra length, so I will get 138.5 inches in this, and the number of bar in main bars in column is 4, so so in member is 1. Now the total length in inches will be equal to cut length multiplied by this number of bar. You will get this 554 inches, and this, if you want to calculate this in feet, so convert this into feet. 554 divided by 12, okay, it is 46.16 feet. Now the main bar diameter is it is a number 6 bar, so for number 6 bar you will get the diameter of 0.75 and weight is 1.502. Now now here the diameter is 0.75, okay, inches, and the weight is 1.502 Okay, in the rate of weight is 1.502. Now the total weight will become this length in feet multiplied by this weight in pound per feet. So you will get the total weight of 69.33 and it will be in pounds. Now this is the bar bending schedule for column for main bar. Now I have to calculate the stirrups as well. If you can see here, this one, these are the stirrups, and if you take a look closely, the stirrups are only above the footing slab. It is not inside the footing slab. The steps are not provided inside that footing slab. So now we will calculate the number of stirrups, and the formula that we got is it is 117, because the length of the pile above the footing slab is 117 inches. Divide this by the center to center spacing, which is 8 inches, and add 1, you will get the number of stirrups, which is equal to 16 numbers. Okay, and if you take a look at the cross section of this column, you will see here the length of the stirrup will be this is, if you can see here, this is, okay, it is 9 inches, I guess. Yes, you the length of one side of this strip is 9 inches, so it is a square column, so the other side will also be 9 inches. Okay, so the length of for that actual length for that strip will be 36 inches. Okay, you already subtract the clear curve from that, so no need to subtract again. So in number 3, it is stirrups. Okay, I have already inserted the shape code for that stirrup. Okay, here the actual length is 36, and there is no clear cover, and the extra length is these hooks. One is 3 inches and there are two hooks, so it will be 6 inches. Okay, and then the cut length will be actual length plus this, it is 42, and the number of stirrup is 16. Okay, and the member is 1. Now inches, in inches it will become 42 multiplied by this number of bars, it is 672. Now now convert this into feet. What I will do, I have to divide this by 12. 672, now 56 feet. Okay, 56 feet. No, it is 672, that is 56 feet. Okay, so now we are using the number 3 bar. Okay, number 3 bar. So for number 3 bar, the diameter is 0.375 and the weight is 0.376. Okay, so the diameter is 0.375. Okay, and the weight is 0.376. Okay, here you will multiply this feet with this weight, and you will get the total weight in pounds. Okay, if you want to calculate the total weight, okay, what you have to add these three. Okay, you have to add these three, you will get the total weight of 147.5 pounds. So this is the bar bending schedule for column and footing. And you can also prepare a bar bending schedule for column and footing. If you just have to follow this procedure, and you just have to you have only to have a plan of column and footing. If you have a plan of column and footing, you can prepare easily bar bending schedule for that particular column and footing. So guys, if you like my video, give us a thumb up, and don't forget to subscribe to my channel. Until then, it's a goodbye. See you in next video.